Hey everyone, hope all are doing fine and enjoying the conference so far. This is me, Gokul Prabagaren, and I have my colleague Rajesh Srinivasan. We both are from Card Rewards R, and we are very excited to bring our topic, evolution of CICD in CapitalOne to you all. In fact, we both have been with the CapitalOne for many years, and we have lived this journey, and this topic is very near and dear to us for that reason. So before we dive into the topic, some details about CapitalOne. So CapitalOne is the first US bank to exit out of on-prem legacy data centers and go all-in-all cloud. You can imagine like how much of cultural shift and technological shift a company has to go through for this kind of a major change in their whole journey they have to do. Right, for that, the technology has to stay in the center of whatever things they do. And that is the primary reason. Now we are a tech company which happens to do with doing the banking business. And that's how we operate and that's how we think. And we are a founder-led company which stays true to its mission of change banking for good. And that also primary reason, like there are a lot of ways in which we give back to our communities, and specifically when it comes to the tech, we have contributed more than 20 plus open source projects to the community. And to name few, Critical Stack, which is a security focused Kubernetes offering, which is a widely adopted one, and Rubicon, which is ML model tracking tool. And we have invested heavily on CapitalOne's Coders program. And this is a program which is sponsored by CapitalOne and run across multiple middle schools. And this program mentors and motivates, inspires middle school students to embark on a journey and see themselves as future technologists. And similarly, there is another program called CapitalOne Coda. This program paves way for non-tech folks to get into technology stream. And these are few ways specifically we have called out in tech space we are giving back to the community. To start with, here is the quick glimpse of our CICD journey, also on agenda. First, we will start with how we were doing our deployments a decade ago, primarily in on-prem, and how things were dealt, and how and why we have decided to build a lot of foundational capabilities when we decided to embark on a journey of being a technology company, and why those things are needed if you have to do or if you want to go through the similar journey, and what were our initial baby steps when we started crawling in that space, and what are the few consequences which happen, and what are some missteps, and how we standardize all those things, and how we are currently running base in our current environment, and what are our aspirational things which we have in our roadmap to go to moon, leaving some room for Q&A. So let's start with how we were dealing things a decade ago. That's what we are calling it as on-prem or L3 support. Right now, so we are a 100% cloud operated company. A decade ago, like any other bank or any other company, most of our IT operations were outsourced and it was dealt by vendor teams. And typically, dev team requests for a capacity in on-prem server to deploy their application, and typically system team which allocates them, and once the feature build is done, dev team throws that build over the wall to the system team and they deploy it, and they hand it off to ops team and they manage the things in production. And that's how most of the things were done. It's not only specific to us. This will definitely resemble with all of the folks who have gone through this kind of things when we're dealing with on-prem things. And this is also not a surprise for folks who deal things in on-prem environment where ops team manages a lot of their production things. Right? That's what we are calling it as L3 support. And whenever there is an issue, ops team comes back to the dev team. Hey, this is something reported by customer and we are seeing it's not working. The immediate response probably is, hey, it's not a bug, it's a feature. Right? The main reason for that is dev team really doesn't have a lot of insights in how that build, whatever they produced, is used in production. And same way, ops team doesn't know how that was built and what was the feature in specific they have built, all those things. They both doesn't talk same language. If you see from that view, right, there were a lot of things we actually had to do when we decided to take on an aspirational journey of being a tech company. And there are a lot of things we have to build as a foundational capability for us. And we will see what are those and how and why we decided to invest heavily on those kind of foundational pillars. Say previously mentioned, most of our IT operations were outsourced and it was built by a vendor specifically a decade ago. And we were doing things using typical waterfall model. And you can imagine how long that kind of approach takes idea which was originated and to realize that in production environment for customers, right? That kind of environment is where we were operating, and we decided to take on a journey. And holistically, these things is more towards technology and also specifically on CICD. Like we decided to take Agile as our primary methodology in which we want to develop software. And this kind of decision when we made, and this actually has helped Agile teams and their engineers to have a lot more power and the decisions what they have to make, right? It's more local, and with that, they were able to move faster and deliver business capabilities even more efficiently and quicker and be a nimble team, right? Which is what has actually enabled us by picking Agile as our primary methodology from where we were doing things. We have adopted you build it, you own it, DevOps culture. And having a dev team and ops team as a two individual units, like there is always an imaginary wall which stays between them, and they don't talk same language. And you can imagine that kind of conflict actually reflects in how and when the customer feature and customer experience when it comes to the business intents being delivered, and that kind of things actually derails and that impacts the customer experience holistically. And by adopting you build it, you own it culture, now engineering teams and specifically engineers, they feel more empowered to make decisions for their teams. And this kind of environment actually fosters lot more innovative working environment, and because they make the decision which impacts their teams, and be it a technology or whatever the things which impacts them, and they make the decisions, and they own holistically from getting involved in business teams and taking from start till the end and manage them, right? That gives the engineering teams a lot more ownership. And another main advantage of doing this way is you don't need ops team to reach out to dev team. Hey, there is something happening. We want to resolve this. No, you don't need to have that kind of derailing conversation. Whomever they have delivered, those engineers are pretty close to now. Whenever the things are reported, and they know the things because they have delivered. That's the primary advantage of doing you build it and you own it. And next thing is open source. Years ago, like most of the things, how we were doing software development itself is primarily on top of vendor specific commercial COTS products is what we have used throughout our tech stack. But that kind of environment doesn't actually foster a lot of things which we want to take it to production as a business context, and you cannot innovate that quicker. And whatever the knowledge engineers gains, right, that is bit more vendor specific knowledge, and it stays with brains of few people, and that's not what engineers actually want to do. That's where we made a declaration to adopt open source as our primary way of doing software development. And this kind of standardization actually helps to propel your journey for long term, right? Open source being the standard way of developing the software actually empowers the engineers, and whatever the skills they acquire is not more vendor specific. These are standard across the industry now. And what they do is on top of open source, and that's what engineers love to do. Develop on open source, contribute to open source. So as was previously saying, most of our things what we were doing previously was on on-prem legacy data centers, and it was managed by vendor-specific ops teams. Right? You can imagine that kind of environment. Let's say some incident happens, and can imagine the time in which we respond to that kind of things. Right? Those kind of issues or addressing the business context, all those things in legacy data center perspective, like it takes days. Like there is a very rough estimate that in those environments, it actually took months to deliver a business feature to production. Though these things were, we were discussing within ourselves in our organization, but in 2015, we made a public declaration that we want to go all in cloud by 2020. And last year in 2020, we have actually achieved that, and we exited completely out of our legacy data centers and we went all in cloud. What this enables is now you don't need to deal with various environments, be it on-prem or hybrid. You don't need to invest your resources for doing a lot of things which are very much specific for maybe on-prem, or you're having something in the cloud. You cannot achieve that standardization cross board. What we are seeing from making the declaration adopting cloud as our primary infrastructure component is that standardization is propelling our journey into the tech space, and we are able to see a lot more innovative things coming out of this, because we are not spending our engineering capacity and engineering smart brains in doing a lot of the routine mundane work, right? Instead, those things are invested in delivering business intents and making customer experience better. That is what our primary mission as well, right? Cloud is primary one which is actually enabling us to deliver that kind of thing for our customers. And this is not a real depiction of all the things, but this gives an idea that we have heavily invested in making developers life easy, right? We don't want to do it anything which is old legacy way of dealing things, and instead we have heavily invested in lot more standard engineering tools which actually enables them to deliver things faster in more innovative ways. Primarily, whatever they deal with doing things, right, they are not doing anything on proprietary vendor specific commercial things. Those just gone. It's primarily on standard engineering tools, because whatever they do, it's a standard across board, right? What they are using here, it's used widely across the industry, and this is what actually enabled our engineers to deliver things pretty faster. And there are there may be a lot of companies which probably might be in a part of this journey, or maybe thinking to go through this journey of primarily doing all these things in an automated way, CICD enabled, right? This is just how we thought, and this is just an example of how we have parked this journey, right? There are various foundational capabilities we invested. Companies may be doing one of these, two of these, but all these things actually has to come together and do things cohesively, right? Adopting, you build it, DevOps culture along with Agile methodology and doing things with the right engineering tools on top of open source software in cloud, right? This all has to come together, and this is what actually made us propel our journey into the company as a tech company. And CICD being a critical component of this and how we deliver software now is primarily done everything through automated pipelines, and that's how we primarily deliver the software. Now let's see what are the ways in which we have actually started doing things in our initial days of adopting all these foundational capabilities, and we started doing things in CICD in a specific way. As any other nascent technology, and when there is a things happening, and you probably may not completely get, hey, what is the full potential of those things, right? That's how we were initially doing things. And when we started our journey into the CICD space, hey, and Jenkins is our primary CICD tool for doing all these things. By the screenshots, you probably may be able to recognize that. And how we have dealt is having most of this capability, what we need, those were embedded in those specific jobs or pipelines as Groovy scripts. And you can see the screenshot attached. And we have actually gone through so far in our journey, and I really couldn't pick up any of our real Groovy scripts, which we have used years ago when we started this journey. And these are just the samples what we have used. You can see the primary issue with that approach is scalability. Like, let's say you have defined some specific security scanning tool, or maybe a unit test tool, or way in which you build your component. All these things, for some reason, you want to change, right, from A to B. Making that kind of simple adoption is pretty hard with this kind of custom scripting, because the impact is huge, right? Those were the initial things how we dealt in years ago, and those were kind of missteps we did. And from there we adopted a different path. And to take us through the journey, my colleague Rajesh will continue from here.
Hey, thanks, Gokul. That was a good build-up of the story. To continue with the story of how CapitalOne has evolved in this CICD journey, as Gokul mentioned, CapitalOne started developing what we call it as a pipeline frameworks, right? So just to give you some context, a pipeline is where you have multiple stages to basically build your code, to do the scanning, to do some testing, and also to deploy them that at a high level. And we wanted to be able to do it in a consistent and a repeatable manner without compromising on the quality of the deliverable. So as you can imagine, CapitalOne being such a big company, we had multiple lines of business, and the technology divisions within each of these lines of business, they started developing pipelines. So in no time, we started to have multiple pipelines belonging to these lines of business, but each of them pretty much doing the same thing. While it may not be exactly the same, they had a lot of common functionalities, and there was not much standardization that happened across these pipelines. And most of these frameworks were also addressing use cases specific to the line of business. It was not kind of generic enough. And in order to be able to deploy the code all the way into production, we need that kind of a stages to be well defined to say, hey, these are all some of the pre-approved stages that you need to have to be able to take your code into prod. And that those things were not well defined. So this is where we started getting into the standardization. So this is the phase where it was all about standardization and automation. As a company, it was very clearly realized that, hey, we need to have one pipeline. And that is where we started going towards. The directions came from top down to say, everyone needs to now adopt a single framework. This particular framework was an internally built framework on top of the Jenkins tool. The goal was to make it as easy as possible for the developers, because this pipeline was not only used to deploy the code, it was also used to deploy our infrastructure. Basically, you can kind of pretty much think of anything that needs to be deployed, whether it is an infrastructure or it is a code, it will go through the pipeline. We kind of call it as the one pipeline. The effort started going in towards standardizing, hey, if it needs to happen through this pipeline, what are all the stages that need to be defined? That is where we started having like what we call it as a pre-approved release. If a code needs to be released through this particular pipeline, we had around almost 16 stages. It includes standardizing how we do the scanning, what are all the tools that needs to be used for scanning, what are the levels of vulnerabilities that we need to fix before a code can be deployed to prod, depending on the criticality of the application. What kind of testing needs to happen, whether it is a functional testing or a performance testing. What kind of testing needs to happen? How do we capture the results? And also what kind of approvals needs to be built into the process? And finally, how the code can be deployed. So all these stages were clearly defined. It was all standardized, and we started moving towards this one framework. While this process, it facilitated the push button deployments. It also ensured that the changes are reviewed, approved, and are free of vulnerabilities, tested for functionality performance. So basically, we were able to start doing fearless release into production at any point of time. As we started getting into this, if you can go to the next slide, please, Gokul. As we started getting into the standardization, right, what the standardization also helped us was that it enabled us to do a lot of inner sourcing. We were able to share share with our community, the developer community, to say, hey, guys, you can now start contributing to this community. So that opened up a lot of engineering innovation. And as part of this framework, we started building something called Gears, which is basically a reusable component. Say, for example, if you want to now create a Lambda as part of your pipeline, we started moving towards this Gears. Basically, then all that engineers have to do is to provide some declarations to say, this is the name of my Lambda. This is what, these are all the configurations I need. Similarly, that goes into any other AWS infrastructure component that they needed to build. All those things contributed towards not reinventing the wheel, and this also gave us a lot of time back to our engineers to focus on the business intent, because all the standardization it provided all the other components that are required as part of the pipeline. Also, as part of this pipeline, it started supporting multiple deployment strategies. As you can imagine, when we deploy things, critical applications into production, particularly the application that takes some real-time traffic, we need to absolutely ensure that the code that is being deployed works in production environment. This is where we started adopting strategies like blue-green deployment initially to start with, where basically as part of the blue-green deployment strategy, you create your infrastructure, you deploy the new code into production, and then you ensure that the code is working and stable before you decommission your old infrastructure with the old code. So all these things were able to, all the end result of all the things were that at this point, around 80% of our deployments are going through this, what we call it as the pre-approved release process. Approximately 15,000 deployments are being done over a month. And many teams are now able to do more than one release per day, compared to a release taking weeks and sometimes even months before we started going through this journey. So that is the kind of effect that we are able to get by adopting this process. And now, looking into some of the future, we are now beginning to build on top of this pillar. We call it as we talked about some of the pillars. Plus, we also have this platform called this one pipeline. Now we are building further on top of it. One of the key things that we are looking is shifting left. As we are doing rapid releases, we want to ensure that we identify any issues or vulnerabilities as early as possible in the development process. So this is where we have started using some tools for both the open source scanning as well as the static scanning, which will identify vulnerabilities way early in the development process, and it also integrates with Git. So the engineer who is developing the code, they will get to know what are all the vulnerabilities they need to fix as part of the process and not have to wait until it gets into QA or further down the line. Similarly, we are also putting a huge focus on the peer review, which is also one of the stages that goes into this CI/CD process. We are encouraging the peer reviews to be as effective as possible, again, in the interest of identifying issues early in the process. We are also working on, this is something that has been already rolled out, and we are in the process of having a lot of applications adopt this, what we call it as the managed pipeline. This managed pipeline is basically going to give the ability for a component to be onboarded. Basically, we provide a UI. The engineer, all they have to do is go in and put some information. It is kind of very self-explanatory, where they fill in a lot of information and click few buttons here and there, and then boom, they have the pipeline ready, instead of the engineer needing to invest in creating the pipeline, the different stages, etc., etc. This is also give more control for the enterprise to say that, hey, these are all no one can bypass any of the stages that are needed, and also establish the security standards that are needed as part of the pipeline. CapitalOne is also in the process of developing more and more reusable gears that will go into our library. Again, all this goes back to the concept of reducing or abstracting our engineers from the nitty-gritties of creating all these pipelines and focus more on innovation and new intent development. Because the developer time or the engineer time is a very, very critical commodity, and we are trying to save as much as possible by adopting these platforms. One other thing that we are looking as part of the future is canary deployment. While blue-green deployment is great, it does have its own cons. So with canary deployment, what we are going to be able to accomplish is that in production, we will be able to adjust the amount of traffic that goes into the new code and kind of slowly increase it. We have all the monitoring in place to ensure that the new code is absolutely working before we increase the traffic and at some point get that to 100% and then decommission the old code. This is going to further help us reduce any production incidents as part of our deployment. And again, go back to the phrase of fearless release and able to release at any point of time that we want to. So these are all some of the stuff that we're planning to do in the future. Again, as a summary, this journey has not been easy, right? Kind of Gokul talked about where we started, and where we are. The key things are to be able to use the right process and the combination of right process and right tools. That is how CapitalOne has been able to come so far. And yeah, we are continuing to evolve, but we have already started seeing the fruits of all this hard work that has gone in. The combination of all the engineers in engineering innovation, plus all the tech leadership. Let's go to the next slide, please, Gokul.
Yeah, if you liked our presentation, you can hit us in LinkedIn and Twitter. I have included my details, and I think Rajesh details are also here.
Yeah. And finally, CapitalOne is hiring. As Gokul mentioned, CapitalOne is now a tech company doing banking. If you're interested, you can go to the CapitalOne.com site and look at what are the job opportunities that are available. Thank you. Thanks for your watching this, and thanks for your time. We appreciate it. Thank you.
What's in your wallet?